Hey, what's going on, guys? KMonKeyNZ here. It's been a while since the very last video on this channel. So in this one, I would like to share an ultimate approach, I would say, to an absolutely free, freely available and most common web scraping techniques that are intended to bypass simple anti-scraping measures. So we're not talking about captures. Please don't ask me about the captures, as like I said before. If you want to bypass captures, either try not to get into one or pay for data. That's the best way of doing things. Just legally extracting the data and avoiding web scraping, because web scraping is going to be, it's a gray zone now. It's going to be illegal one day, so you really shouldn't be taking advantage of this that much. So me personally, I'm currently heavily studying some new routes to consider instead of web scraping, and just because I'm still kind of forced doing that, I kind of need to come up with some sort of a tools. But anyway, so still there is a small niche of the websites that are kind of available for to be crawled using the kind of freely available methods of bypassing the anti-scraping measures, simple measures they provide. So I've created a script, or a class better to say, so it's called HTTP request spoofer. So what it is, basically, it's a library with a that simple interface that wraps around Python request get and post methods to come up with the get and the post requests that do provide the random user agent. So every time you make a request, you have a random user agent on the one hand, and another option is to make every request a newly scraped free proxy. So it doesn't always work because all those proxies are not available, I mean the free ones, but in most cases it does. So I will now demonstrate how this works, and then probably I will demonstrate how this works in a real world project I'm currently working on. So kind of it's the experience of the years of the web scraping I've been doing so far. So I was using Scrapy for years as well, but eventually we came to good old Request and Beautiful Soup, and actually trying to incorporate all those freely available web scraping techniques because they kind of seem to be working the best. So without further ado, without looking at how it works at the moment, because I want to walk through the source code and can explain this in a little bit more details for those interested in how this works. And as for the usage, so here I provided a simple snippet. So let's just open a console and just try to run this right out of the box. So Python 3, and here well, actually all right, so I can't do this because it's not installed by a pip installer or something, so I need first to download it. So where is, actually probably I don't yet have it, so I need to download it, and here I just say git clone. So it's really important to have this being downloaded, because otherwise it's not really going to be working. And go into source, and here where I have this scraper.py. So here we have the test. The test literally duplicates all the tests being available here. And by the way, we can actually run this file straight away. So yeah, I think I just run this file in order to avoid some boring stuff. So just say Python 3 and tests.py. Tests.py. All right, so by the time it's running, so what we got here, so first we're importing everything from the scraper, scraper.py file. So here is the file. It has the request and Beautiful Soup being bundled inside, and also it does rely on the library called random user agents. So here I have the requirements file, which you can make use of in order to install everything to make it work, right? And we'll come back to this class later on. So let's have a look at the output. So it makes if you want to override the headers, this can be done very easily like this. Just saying scraper.headers, and then you just override the values. Then the user agent would be rotated automatically every request if that option is actually being if that option is being enabled. So the default settings are the following. So we have the use proxy. So these are the keyword parameters. So the use proxy by default is equal to true. Spoof agent by default equals to true as well. Try stands for the number of tries to it's kind of recursive function that tries to scrape the list of free proxy lists. So if it doesn't come up with any decent ones, to try again, up to number of times being defined here. And the delay is simply the delay between the HTTP requests that are going. So literally, if you're doing this in a loop, so like the delay before making a request, you cannot specify this delay before the request, but you can just make it when the object is created. So just to give you an idea, just to play around with the parameters a little bit at the moment. So it just testing the proxy. So here I'm not sure which exactly. Yeah, these guys repeating here is actually the cases when the library fails to upload to come up with a decent proxy, because free proxies are not always on the cards and they are not working stably. So the way I approach here, I made it literally saying the following: if you can find a decent proxy, then just try to fetch it and try to make a request via that proxy. And if you're lucky enough, that works. However, if you didn't manage to get that proxy, or you didn't manage to make it work, even though you've just tested it, it's been tested quite a few times. But sometimes even if it was just tested, it was fine, but then you make a real request and it doesn't work. So that also happens. And also you might be wondering why not many requests. Well, in theory it should be resulting in many different proxies if only they were available. But unfortunately, when I just started talking about how exactly I was using those proxies, which one I scraped, this values would get more clear. So what I can say here, that actually the only proxy is this one. That was the library managed to scrape. The rest are the default API, the default IP address. So only a few times it managed. However, from the practical perspective, and based on the results I had on the real-world project and projects I'm working on, this actually makes sense, and this does increase. It does help to fool the dump anti-scraping measures a little bit, and it results in quite a random behavior, because no one knows what proxy would appear just the next moment, right? So also it mixes with your own IP, so which also is sort of a variety. So anyway, now let's have a look at the responses. So here we have the URL where we can inspect the responses. So just copy this one and go into my browser and paste it in. It's just request.bin.com and just a regular endpoint. So I'm just wondering why those were to GET requests. Excuse me, please. Oh, that's because, okay, so let me just delete this request first, and I just run this again. So just run this again, and potentially the working free proxies, like literally one of them in most cases, might be a little bit different. So yeah, okay, we got a GET request, and the next should be a post one, right? And yeah, then we get a post request. Okay. So here, what I want to show you guys here is if we have a look at the header. So well, first of all, I do use this custom header just to make sure they are really custom. I use this your custom header with a custom value, which is available. Your custom header here. And let's have a look at the user agent. So here we have the Linux Android 5.1.1, and here we have a user agent, Windows NT 5.2. So it's different user agents. So you see, like by default we have this option spoof agent equals to true, which means that we do actually spoof the user agent. However, if you want to disable this, you can say spoof agent equals to false. And then also, if you don't want to use the proxies, you say use proxies. If you don't want to try using proxies, you can make it equals to false as well. And then you might want to provide a custom delay of, say, let's give it 2 seconds, for instance. And here, yeah, just still fails. So it still tries the local IP. So sometimes it doesn't ever fetch the real free proxy, because, like I said many times already, they're not stable. They might be used just once or twice, and then they may just die. So it's not something that relies completely on this free proxies, but just tries to pick up one. You know, like the logic of how this is written is way more elegant and beautiful as opposed to how this works, like it often happens. Yeah, but anyway, well, I'm not even sure. Yeah, probably just goes into the recursive fetch cycle to trying to come up with some new ones. Yeah, I should actually wait. And also, it's really hot here, and my laptop is heating so strongly. So yeah, it starts being really dumb here. But anyway, I just don't want this to continue. So let's run again. Tests.py. I want to run the tests. .py. So what I want to show you now, guys, is the following. So let me just get rid of this requests. So now if I run this again, excuse me. Sorry, not use proxies, but use proxy. All right. So now it would make another 2 requests, but this time the user agent would be the same. So let's just have a look. So here we have the user agent. This is actually my actual user agent my browser is using, so Linux x86 64, and this one it should be exactly the same. So yeah, it's exactly the same. So that's clear and makes sense. And now you see, like, now IP would always be just my local IP, because I'm no longer using those that option to actually spoof the IP. So in this case, this is just a regular Python request library, which you can just use it without actually using this particular thing. But for my particular purposes, I'm encountering on those real world web scraping projects I'm currently working on. So I do encounter a need. So sometimes I want to use this custom proxy, sometimes not. So it's helpful. It's really easier for me. It's more handy for me to follow to go kind of this way. So just make it back, and actually we're done with this code. We no longer need it. So how to use it? So you just create the scraper instance, then you can say just scraper.get and this and the URL, just like the request.get, the regular Python request. And for post, it's a little bit different. So you just put this data as the Python dictionary, which is the request body in this parsed format. So that's important. So that just forwards to Python request the post method. So nothing special here. And now, finally, let's have a look at the source code of the library, because I know it wasn't really, I know this really wasn't like, what the heck was this? Oh, whoa. It's interesting. Okay, so it wasn't that impressive, really, I know, but I spent quite a bit of time actually developing this, so I just want to show you how this works. So the initialization part, well, initially headers only contain the user agent. So if you don't override them, you only use the user agent. In most cases, in my experience, like for years of web scraping, this is usually enough, because if you need some specific headers, most likely it involves some complicated scraping measures that you're not really capable of bypassing, because people are spending like $1,000 to protect their data and like using neural networks to detect the bots, and that's just kind of next to impossible to beat that and to bypass that. All those captures arising and so on and so far. So, but actually on practice, just having the random user agent is usually fine. So here I'm initializing the parameters the class is taken on create time, when the constructor is created, basically. So this part is just a copy paste from how to use the random user agents library, and then it just has this interface to get the random user agent. And then when I make the request, I just say that if the spoof agent parameter is equal to true, that I'm just calling this get random user agent, and having this being spoofed. So that's how it works. Then the get random proxy is one of the most interesting parts here. So what it does, so first of all, it's a recursive function. This function calls itself recursively in case if it doesn't succeed for a number of times. And this try stands for a number of times of how many tries this get random proxy function have to succeed. All right, so if it just runs out of tries, then it returns an empty object, which means that it didn't manage to come up with a free proxy that actually works. And in this case, this is one of the cases where, if no other exception occurs, this is one of the cases where when your default IP is going to be used anyway. Then the proxy list. Proxies is the proxy list where the working proxies are about to be appended. Then I'm requesting the freeproxylist.net, which is fairly well known, I believe. So you just I like this among others because here not many, but at least they kind of work. And actually there are much more than this amount. But here is another interesting thing. So here we have anonymity, so only elite proxies actually working. And then the HTTPS support. So this is also absolutely essential. So if you just pick up only those having the HTTPS support and anonymity equals to elite proxy, there would be so here, well, generally it's more than it's seen here. It's around 200 or 300. If you have a look at the page source, I just want to give you an idea what am I talking about here. So yeah, finally. So it's quite a lot. So it's quite more than it seems it is there. And I'm not sure. Yeah, so we can go in further on. So it's quite a lot here. But only around from, I would say from 10 to 12, somewhere around that. Maybe from 10 to 15, maybe from 8 to 16, somewhere like something like that. That is the number of proxies that both elite and do support the HTTPS. But despite the fact they has been checked like some seconds ago, most of them, right? Still, actually, I do recheck them again. So what I do next is, so I do extract all the proxies here. So here is a list of all the proxies. Then I only pick up those that are elite proxies and those that do support the HTTPS. So this is how I select those. And here I form a proxy object that is going to be used here along with a Python request library. So then I do make this GET request to the ipfi.org, which just returns like whether your proxy worked or not. And I'm setting the timeout equals to 1 because I only want to use those proxies that are alive. So most likely if it doesn't respond in 1 second, then most likely either it's not working or it takes like 5 seconds to make a request. It's kind of too long, so we're not interested in that. So in case we have a status code for the given response equals to 200, which means that the request has been the request was successful, right? In this case, we do append this proxy to the list of proxies. However, if you just put a print statement here, then you will quite nicely you will realize that the number of proxies here in this list from 1 to 2. So quite often it's just 1 or 2. And then if the length of this proxies after this procedure is more than 1 or more, and then it just picks up a random one. And again, like even if it just makes 2 proxies, for instance, then you call this random, it may pick up one of those like more times than the other. However, in practice, this still kind of works. And I was trying millions of different approaches, like crawling through the list in a for loop, trying to use every given proxy, etc. But all those were not as stable as I wanted them to be. So even though this one looks not maybe not really nicely, it kind of the most efficient one from the practical perspective I came up with for within these years. All right, and then finally the functions, the interface functions basically. So here is the wrapper for HTTP GET request, and here is the wrapper for HTTP POST request. The difference is that the POST request has the request body, which is referenced via the data keyword. So if data equals body, where the body is the object that we're sending there. So just like I've been showing you here, guys. So this kind of this Python dictionary object is what then would be parsed into the request data. Into the request data, into the request body. Sorry. So that is quite useful when you're fetching the data directly from the API of some sort. So that might be useful. And so we have a look at the post request, the get request, because the post is only different having this request body argument. So first we do a delay because we just return from the function otherwise, and we can't do delay here obviously. So first we make a delay of how long we should wait. If the parameter is more than 0, this should affect the performance at some point. Then if we are allowed to spoof the user agent, then we do spoof it, and then we are getting the random proxy. So in case if we're allowed to do this, we're getting the random proxy. Otherwise, we're just using the empty object. So your default IP would be used otherwise. But let's assume that we are using this random proxy. So let's assume that get random proxy returns a single random proxy from that proxy list in the function above. And in this case, we're trying to make an actual GET request that is going to the URL that we're interested in. We're using the headers if we've overridden them or not, and the proxies equals to this random proxy. So here in 90% it should work, but sometimes it might not, and that's the reason for wrapping this code into the try except basically construct. So otherwise, if this doesn't work, this means that even though the random proxy was considered to be like working and alive, but for some reason it doesn't work, so it still tries to actually make a casual request, like just a regular request here. And here, I probably should have wrapped into the try except construct this request as well, but since I didn't do that, it's generally a good practice, just like with the regular request library, to wrap the request into within the try except, just to make sure that if your scraper drops somewhere on a half to the very end, then you just don't lose all you've been doing so far. So it just passes and just tries to keep executing. So here's how I use this scraper.get if we are in a loop. So far so good. And the very last thing, just to impress you a little bit more, I know you were not impressed by this, it doesn't really look impressive, I know that, but just to give you an idea like how exactly I use it, because again, it's not sort of a library that I make just for fun or for YouTube videos or something. That's something I really use on my own when I'm working on my web scraping project. So I just want to give you the following thing. So if I go to my, so here I have the Greek real estate property scraper. Here it is. I can quickly show you the code. Well, it's proprietary. I'm not going to be sharing this, at least for free. But here, what I do, so here I initiate the desired. And actually, I can make it just to show you how this works with those. Just show you how that works with those random proxies. I just disable the parameters to make them being equal to default ones. So I'm just creating this scraper object that I would later be using to make the actual requests. So for instance, here's the request, every property link within the list. We also crawl through the through the range of pages here. But anyway, the way how it works the following: so the try except wrapper, quite standard. So I'm calling it's a sort of a callback function because it's inspired by Scrapy organization of how the code works, but nothing much, just the visual part basically. So here I have the scraper.get and only the URL is specified. While this, unlikely the casual requests, Python request.get method, this one already spoofs the user agent and already provides a new random proxy, a free one, if that is available. Well, this particular code doesn't show if actually that free proxy worked or not, or what exactly it is, because that's the requisite of the client is just not seeing that basically, but it doesn't matter. But when we go with this for a long run, then it generally performs much better and more stable. So so here on the output folder, so just delete this one. Yeah, it's gonna be quite, yeah, so to crawl through the entire site, it would probably take, I don't know, a couple of days. So I just show you the very beginning basically. So Python 3xe.py, and here we go. So the only thing it displays is a TQDM bar, which counts in this case is the number of locations per coordinate regions in Greece, and it also automatically handles the pagination, crawls through all the pages within the given coordinate range, and it takes much longer as opposed to if I don't use this free proxies, because sometimes it may take time to actually get some didn't really result in any single entry being scraped so far. But if one is patient enough, then this would result in actually working. Okay, so here we go. So already having something here. So yeah, well, this is gonna last forever basically, because every category might have like up to 10 or 20 pages, and per page there might be like 36 elements, so it's really long. So this is boring, and maybe in a couple hours this would be like 5%, maybe less, and there would be up to 4 categories like commercial, sale, rent, residential, sale, rent as well. So yeah, that's how it works. But anyway, I just want to make sure, yeah, so here, so it's really slow. It's much, just to give an idea in regards to the difference basically. So for instance, if I just, if I don't use those proxies, if I don't use them, and just run again, and I delete this file, this is gonna be much faster basically, because yeah, so like it goes almost instantly, and yeah, it's gonna be much faster. So see, like it goes really faster. Goes faster because it's like blazing fast, but it only relies on my default IP, which might not be that great. So anyway, I just stopped this here. Yeah, and probably I would end up this video at this particular point. So for those interested using this library, feel free to do so. I'll give you a link in the description below. Just give it a try to play around with. Again, like, doesn't always work in terms of you're not guaranteed 100% to get working random proxy every request, but it kind of makes sense in the long run. That's important. It makes sense in the long run. So again, like, I just made it for my own self, so I'm not really sure if someone else would actually prefer this or not. But anyway, so for you guys to try. This is it from my side. Thanks for watching. Until the next time, and take care.